Can black holes transport us to another universe? Imagine drifting through the endless void of space, surrounded by the silent, twinkling stars. In the vast darkness, a gravitational behemoth lurks, one of the most mysterious objects in the universe, a black hole. For decades, scientists have pondered a tantalizing question: could these cosmic giants be portals to another universe? Tonight, as you relax and prepare for sleep, let us journey deep into the heart of physics, exploring the possibilities hidden within the enigmatic nature of black holes. What is a black hole? A black hole is a region in space where gravity is so intense that nothing, not even light, can escape its grasp. These celestial phenomena form when massive stars collapse under their own gravity, compressing their matter into an infinitely dense point called a singularity. The boundary surrounding this singularity is known as the event horizon. Once anything crosses this invisible line, it is lost forever, at least according to classical physics. But could there be more to black holes than just destruction? Some physicists speculate that these cosmic voids might not be endings, but rather gateways to something beyond, perhaps even another universe. Theoretical foundations. To understand whether black holes could lead to another universe, we must explore the complex theories of modern physics, relativity, quantum mechanics, and the speculative realm of wormholes. Albert Einstein's general theory of relativity suggests that space and time can be warped by massive objects. This warping effect is what allows black holes to form, creating regions of extreme curvature in spacetime, but relativity alone does not fully describe what happens inside a black hole. To unlock deeper secrets, we turn to the strange world of quantum mechanics, where particles behave in ways that defy classical understanding. Could the fusion of these two theories suggest an escape route beyond the event horizon? Wormholes, bridges through space and time. One of the most fascinating ideas linked to black holes is the concept of a wormhole. Proposed as a theoretical solution to Einstein's equations, wormholes are hypothetical tunnels that could connect two separate points in spacetime, or even different universes. If a black hole were connected to a corresponding white hole, an entity that expels matter instead of swallowing it, the resulting structure could form a traversable wormhole. This idea suggests that falling into a black hole might not mean total annihilation but rather a passage to a distant location. However, there's a problem. Known solutions suggest that such wormholes would be highly unstable. Without some exotic form of negative energy to keep them open, they would collapse instantly. Still, some physicists speculate that if a black hole were naturally connected to another universe, it could act as a one-way portal, a cosmic door through which information and matter might travel. Black holes and the multiverse. The concept of the multiverse, the idea that our universe is just one of many, raises another intriguing possibility. If multiple universes exist, perhaps black holes serve as conduits between them. Some theories suggest that when a star collapses into a black hole in our universe, it might give birth to a new universe on the other side, with its own unique laws of physics. This concept is explored in Lee Smolin's cosmological natural selection hypothesis, which proposes that black holes could be the seeds of new universes. Each time a black hole forms, it might lead to a baby universe, with physical constants slightly different from our own. While speculative, this idea suggests that black holes are more than just destructive voids, they could be cosmic creators, giving birth to an endless chain of universes. What happens if you fall into a black hole? Imagine yourself drifting closer to the event horizon of a black hole. From the outside, an observer would see you slow down, your image stretching due to gravitational time dilation. But from your own perspective, you would feel yourself accelerating toward the singularity at an unstoppable rate. If the black hole were a simple Schwarzschild black hole, your fate would be sealed, crushed into an infinitesimal point of infinite density. However, some theories suggest that under the right conditions, you might not be destroyed, but instead, transported elsewhere. Could this elsewhere be another universe? Some physicists believe that. If quantum gravity effects allow for a bounce instead of total collapse, the singularity could act as a bridge. This aligns with theories suggesting that inside every black hole lies a new expanding cosmos, a reality disconnected from our own. But there's a major problem. we currently have no way to test this idea. The extreme conditions inside black holes prevent us from gathering direct data. For now, the possibility remains a tantalizing mystery. Black holes in string theory. In the realm of string theory, the universe is composed of tiny, vibrating strings rather than point-like particles. This theory introduces extra dimensions beyond the familiar 3 of space and 1 of time. Some variations of string theory propose that black holes could act as interdimensional gateways, potentially linking our universe to hidden dimensions or even parallel realities. One idea, derived from brane cosmology, suggests that our universe might exist on a vast, higher-dimensional membrane, or brane, within a larger multidimensional bulk. Black holes might punch holes in this brane, allowing information, or even entire physical entities, to escape into another layer of reality. While these ideas are still speculative, they open up fascinating possibilities about the deeper nature of black holes and their potential connections to unknown realms. Hawking radiation and information paradox. One of the biggest challenges in understanding black holes is the information paradox. Stephen Hawking proposed that black holes are not entirely black, they slowly emit energy in the form of Hawking radiation. Over immense periods of time, this radiation causes black holes to evaporate, but if nothing can escape a black hole, what happens to the information about everything that has fallen in? According to quantum mechanics, information should never be lost. This contradiction, where information seemingly vanishes forever, poses a deep problem for physics. One possible resolution is that the information is not destroyed, but instead escapes into another universe. If true, black holes might serve as one-way tunnels to a parallel cosmos, carrying imprints of our reality into an unknown beyond. Observational evidence. Can we prove black holes lead elsewhere? At present, we have no direct evidence that black holes lead to other universes. Our current understanding is based on mathematical models and theoretical physics rather than observational proof. However, scientists are making progress. The Event Horizon Telescope has captured images of black holes, giving us our first direct glimpse of these enigmatic objects. Advanced simulations and future experiments might eventually provide clues about whether black holes connect to other realms. In the future, if we discover anomalies in black hole behavior, such as unexplained emissions, energy signatures, or distortions in spacetime, it could hint at something more. Perhaps, hidden deep within the darkness, lies a doorway waiting to be understood. The future of black hole research. As our technology advances, so too does our ability to explore black holes. Future telescopes and gravitational wave detectors may provide deeper insights into their nature. Quantum gravity research, including efforts to unify general relativity with quantum mechanics, could reveal whether black holes truly lead to other universes. The development of holographic theories, like the AD/CFT correspondence, suggests that information might be encoded on the event horizon, hinting at a deeper connection between black holes and hidden dimensions. Additionally, advancements in artificial intelligence and quantum computing may allow us to simulate black holes with greater precision, helping us uncover the mysteries within their depths. One day, perhaps humanity will develop spacecraft capable of safely observing a black hole up close, or even attempting to send probes beyond the event horizon. Until then, we can only speculate on the possibilities that lie beyond. So, can black holes transport us to another universe? For now, the answer remains unknown. Theoretical physics offers tantalizing possibilities: wormholes, quantum bounces, hidden dimensions, and multiversal gateways, but without direct evidence, they remain speculative. Yet, black holes continue to inspire awe and curiosity. They remind us that the universe is far more complex and mysterious than we can yet comprehend. As you drift into sleep, let your imagination wander beyond the stars. Perhaps, somewhere in the vastness of space, a black hole is not an end, but a beginning, a passageway to another reality waiting to be discovered.